Welcome to Unity 6 course part 7. In this chapter we're going to introduce more features and more capabilities in C# script in Unity. And I want to deep dive into the C#, to the scripting aspect. You can access to all chapters and the other parts from the playlist here, and also the link is in the description. We already know about the printing and logging out the messages to the console. Let's integrate the code to the Unity. For example, we want to apply a modification to the game object. For instance, setting it active, setting it deactive here, changing its name, moving it, and so on. And this is the integration between the C# and the Unity. Let's start from the beginning. Here we have a code that we've read in the previous section. Let's remove them. As I said, if you want to add your script as a component to a game object, you need to inherit from MonoBehavior. MonoBehavior gives this capability that you can drag and drop your component, your script, to a game object and add properties, specific properties to a game object. Here we have a subject called field, which when you add your component to a game object, for example this camera, we have some fields. For example, this projection is a field, field of view axis is a field, field of view is a float field with a range, clipping planes near is a field, is a float field without range. Physical camera is a boolean. So we can add many types of fields. Here, let's create a public. Public means, maybe you know about the public and private. Public means other scripts can access to this variable. Private means other scripts doesn't have this permission. But in Unity, public gives you another capability. It gives you a field. For example, we have a float field called speed. Control S and go to the Unity. Alright, click on the game object and you can see a speed field which is float, and you can change its value. You can change it to other types, for example bool, which is a boolean, true and false. As you can see, it's bool, and you can active or deactivate it. Right, if you make it private, you can't see it anymore, and the field capability is available only in public, but we have some exceptions. Public objects, public variables are not so protected, and they have less security, and other codes can access to them. Your priority must be making all the variables private, and in some cases you need to change it to public. But what if we want to access to the variables as fields in Unity, while and at the same time the variable be private? How to do it? I will upload every chapter of the course every week, so make sure to subscribe to the channel and turn on the notification to know about the new chapters and new tutorials. We need to add a square bracket and type serialized field. Serialized field add this capability to see this private variable, this private object as a field in the Unity, and you can see the speed. Let's go further, change it to int and type awake, and here print out the speed, no matter it's float or int. Here we want to see the speed and change it to 31 and run the game. Actually, the code is depend on the input you entered here, and as you can see 31 has been logged out. And here if we drag and drop our code and set it to 15, here actually we will see 31 and 15. We have a one code, a single code, but we can use it infinite times on game objects and set different values. Actually, it's a type of object-oriented programming, but in a different vision. We can add custom classes, create custom classes, and create objects and have a object programming, traditional object programming in Unity, while we can use MonoBehavior and add components to the game objects and achieve this benefit, not using the traditional object creation. Unity can handle this by dragging and dropping the components to the game objects. Alright, let's ignore the basic data types. Let's create a game object. Game object type, which it refers to these objects, and we can assign each of these objects to the game object field. Actually, the number or boolean is not accessible in this field, and here let's change its name to obj, and let's print it out, and it will log out the name of the game object. Here, let's see. As you can see, let's remove this component. As you can see, we have a game object field. We can press this circular icon and pick one of these game objects in the scene, or you can drag and drop a game object to this field, and it's filled out. And here, when we play the game, we can see the name of the camera. As you can see, the camera is locked out. It means this field is not empty, and we have the camera inside it. And we can drag and drop any object in the scene to this field. Alright, and now let's write another thing. Work with the properties and methods provided by the game object class. You can see the structure of the game object class if you press the control and left click. Here you can see it at the game object class inherited from object class, and you can see the structure of it. If you write object dot, you can see all the properties and methods provided by the game object class. Here I will introduce some important properties and methods. For example, setActive. setActive makes our object active or deactive. Here we must pass a boolean, true or false. If we pass false, it will deactivate the game object. If we play the game, you will see the camera will be deactivated. As you can see, we don't have any vision because the camera is deactivated, and its text, it's gray, not white, like directional light, audio source, and so on. And this little icon, which refers the activation of the game object, is unchecked, and here it's checked. We can activate it manually again or deactivate it, but you already know how to control it in the code. What if we write this code in the update method? What happens? Actually, it will run the deactive method 60 frames, 60 FPS per second. Actually, it's an infinite loop, and it will not end. And actually, we can't set it active because it will deactivate it again, and again, infinite times. And we can't activate it again because we write this code inside the update. Update is a loop. I introduced the update, awake, start in the previous chapters. Alright, let's remove this line, and here access to other properties and methods provided by game objects. Call object and name. You can access to the object name, which is a string. Here, as you can see, it's string, and print it or change it completely. You can change it to, for example, my camera, and see the result. The name is camera. Let's see what happens after this renaming. Let's play it. And as you can see, its name has been changed. And you can change the name of the game object in this way. Alright, let's go further. We can check the activation of a game object like this object ActiveSelf. ActiveSelf is a Boolean property which it is read-only. It means you can't change it, you can't write into it. It's read-only. And it will return the activation of the game object. For example, we can write a condition if the game object was active, print the object is active, else the object is not active. See the result. Alright, play the game, and as you can see it says the object is active. Let's deactivate the camera and play again, and the object is not active. Actually, using the ActiveSelf we can check the object activation. Alright, these are the main and most important properties and methods provided by the GameObject class. I will introduce more capabilities of this class later based on our needs. We have another subject called GameObject with lowercase g. What is this? It's a property and different from GameObject type, GameObject class. It's a property provided by MonoBehavior. As I said, when you inherit from a class, the public properties and the public methods will be inherited from the upper class, the parent class. This game object comes from the MonoBehavior and actually refers to the current game object. You add this component to it. It refers to game object. If you add your component to the camera, it refers to the camera. If you add your component to the audio source, it will refer to the audio source. And if we call setActive and make it false, let's see the result. It should deactivate the game object, this game object. Let's see. Object is not involved to the scenario. And as you can see, the game object is deactivated. And you can refer to the current game object using the game object with lowercase g. It's a property. And the last and actually the most important part of this chapter is adding components dynamically. Here we can call add component no matter you are calling the game object with lowercase g or object. This method is available for the game object class. Actually, it's a type of game object class like the object here, no matter which one you use. You can call the add component and you can add component dynamically at the runtime. Here after that we need this sign and write the type of the script or component you want to add. For example, you want to add an audio source or simple code or actually light, no matter what component you want. For example, here you can write simple code, this code. Is it possible to add a component a couple of times? Yes, it's possible. Actually, the simple code has been added to the game object, and we can add another simple code using code or dragging and dropping the component inside the editor, no matter. And here call the method. Actually, add component is a method, but this section is useful for generic methods, and I will explain about generic methods in the future chapters. It's more complicated and it will add polymorphism capability to your codes. I will talk about the polymorphism and generics. Alright, press Ctrl S and see the result. Play the game, but it's not a good code because it will add an infinite loop to your Unity. Actually, it's a trap. Because it will add another simple code component, and the new simple code component adds another simple code component, and it will create a loop for you. And actually, it's working, but it's a trap and infinite loop. And actually, it's better to not do it. Can add another component, for example, audio source. Alright, let's play the game. Here, as you can see, an audio source component has been added to the game object dynamically. You can add infinite components dynamically. And don't write this add component code inside the update because we'll face to an infinite loop like the previous scenario. We can add this component to the object, which is the camera, and any object we want. In the next chapter, I will introduce how to move, rotate, and scale an object using the code or even using the keys on your keyboard or mouse.